Hi and welcome to my channel. My name is Tobias and today we're going to look at the graphical interpretation of the coefficients to a quadratic polynomial. I'm working in this program, this free program called Geogebra Classic 5, and now I'm going to go to the input line and put in our quadratic polynomial. So it's f of x equals a times x squared plus b times x plus c. So that's our general function, and I press enter, and now the program asks us to create some sliders for a, b and c, and we want to. So we just accept, and the default setting for a, b and c is 1 for each of them. So we start with the coefficient a, and let's have an interpretation of that coefficient. So right now the branches of this parabola, the graph for our function, they turn upwards, and that is because our value for a is a positive number. So when it's a positive number, we have a happy smiley. You can see the mouth of the smiley here. So a positive means we've got a happy smiley. If the number goes up, the branches of the parabola are going to get nearer to each other. And if we go towards 0, they're going to spread out, these branches. In the opposite direction, we can make we can let it take a negative value. So let's say minus a half. And now we can see that the branches of the parabola turn down, or downwards. So this is because a is now a negative number, so we have a sad smiley. Again, if the negative number is near 0, the value of 0, then the branches are wide from each other, and if we let the negative number become smaller and smaller, they get closer and closer to each other, these branches. But the biggest part here is a positive number, then we have a happy smiley, the branches turn upwards, and if a is a negative number, the branches turn downwards. Now we go to the value for c, because b is a little more tricky, but c is quite easy. That is the y-intersection of the graph, or the parabola, and the y-axis. So we can see that now it has the value 1, the intersection on the y-axis, and c is 1. Let's slide c up to 2. Then we can see that the intersection between the graph and the y-axis is 2. If we go up to 3, then we can see it's 3. So c corresponds to the value where the graph, or the parabola, intersects the y-axis. Let us take a negative number, minus 3, and we can see that that's also true. So c indicates where the intersection between graph and y-axis occurs. Now we have b, and for b I need a point on the graph, exactly where the graph intersects with the y-axis. Then I go to my fourth window here and go down and pick the tangent, and then I press on the point and on the graph, and then we get a tangent line. And now b is a 1, and this indicates actually the slope of this tangent line. So if I go 1 out of the x-axis, then I go 1 up. That's how you determine the slope of a line, or a tangent here. If the value for b was to be 2, then when I go 1 out of the x-axis, then I have to go 2 up to meet the graph once again. So this time the line section here, or the tangent, has a slope of 2. And let's make b a negative number, minus 1, for example. Then we can see when we go 1 out the x-axis, we have to go 1 down to meet the graph once again for this tangent line. So the slope of the tangent is now minus 1. And every time we see out here that these 3 numbers correspond to these 3 numbers in here, to our sliders. So a is minus 1.5, or a half, b is -1, and c is +3 right now. So this is how we can determine or interpret these coefficients graphically. So happy or sad smiley, intersection with the y-axis, and the slope of our tangent where the parabola or the graph for this function intersects with the y-axis. So that was it for this video. Thanks for watching. See you next time. Bye bye.